Hi there. With this video, I want to explain the process of calibrating an input in Smaart for sound pressure level measurements, why it needs to be done, and some of the features in Smaart. All packages of Smaart version 9 allow for Amplitude calibration, but only Suite and SPL have more advanced logging and metric features. To do it correctly, you'll need a standalone microphone calibrator that plays a test tone at a known sound pressure level for the measurement microphone to be inserted into and calibrated in Smaart. I have the ISOMCON SC1 piston calibrator, but they all work on the same basic principle. It has a built-in loudspeaker that plays a sine wave tone at a specified sound level. This one generates a 1000 Hz tone and can be set to either do so at 94 dB or 110 dB. This one comes with inserts to match the measurement microphone's outer diameter so that it fits nice and snug in the space where the little loudspeaker is. For interest's sake, 94 dB SPL refers to 1 Pascal of sound pressure. Being a standalone software that can be connected to nearly any audio interface or microphone, it is impossible for Smaart to know what the sound pressure is that it is receiving from the audio inputs. Microphones have a sensitivity specification, millivolts per Pascal, and can be found on the manufacturer's spec sheet. This metric refers to how many millivolts is produced at the connector end after the diaphragm is exposed to 1 Pascal of sound pressure, usually playing 1000 Hz. Size and material used for the diaphragm will have an impact on the sensitivity. I have an ISOMCON EMX7150 and it has a sensitivity of 6 millivolts per Pascal. Another important feature of any measurement microphone is the maximum sound pressure level before clipping. This microphone is rated to 146 dB. Audio interfaces have input gain to consider when talking about calibration. This specification can usually be found on the manufacturer's spec sheet and is measured in dBu for the input gain. This is how much system headroom the input has before it clips or distorts. The USB audio interface I am using is the Audient Evo 8, and it has an input gain of 16 dBu. Selecting the bit depth of an interface in the software also contributes to the system input headroom. A lower bit depth will have less headroom than a higher bit depth. Applying a logarithmic formula, we can calculate that a 16-bit selection will have roughly a 96 dB of headroom, and a 24-bit selection will provide you roughly 144 dB of headroom. For SPL measurement, we want to use as much headroom as possible to avoid clipping. Let's look at the signal path to better understand all elements involved. Sound travels through the air and vibrates the microphone's diaphragm. The microphone then sends voltage out of its connection down the cable to the interface. The interface translates this voltage into digital audio and then gets processed in the software platform. Each part of the system has individual specifications to determine the overall calibration. Changing out components or adjusting values will offset the calibration. All versions of Smaart have a calibration tool to display the input signal in SPL values. You will notice that the top right SPL meter is displaying dB full scale reading. In this case, all values are negative, and 0 dB is the clip limit of your system. Any other metrics, such as SPL A-weighted slow, are grayed out. This is because the input selected has not been calibrated. The easiest way to get to the calibration tool is to go to the I/O configuration window. Do this by navigating to the configuration tab and selecting I/O configuration. A separate window will open. At the bottom of the window, there is a calibrate button. Selecting this will open up the calibration tool. Note that this is only for amplitude calibration and not frequency or mic correction curve calibration. Select the device and the input your microphone is connected to. At this stage, you want to position the microphone in the calibrator and turn it on. Select the value of SPL you want to use as the reference signal. In this case, we will select 94 dB. The meter on the right of this window should show you incoming signal. Take note that this signal is representing your system headroom. If you turn up your interface gain, you will decrease the allowed headroom. It is always preferred to do calibration with maximum headroom to avoid clipping your system with the content you want to measure. When all parameters are set and you are happy, press the Calibrate tool. Once completed, it will provide a calibration offset value. You may exit this window. Back in the I/O config window, you will notice that the offset value is now entered in the Cal offset column of the chosen input on your interface. When you change the microphone, cable length, or preamp gain, it will throw out your calibration, and the values shown in Smaart will not be accurate. When you leave the I/O config window, the SPL meter will now show you calibrated positive SPL values. For Smart LE and RT, the SPL features are the same. You are able to calibrate the input and view one SPL metric at a time. The metrics can be viewed by clicking on the drop-down menu. The top left icon allows you to have the SPL meter on a separate, larger window. If you double-click on the SPL value, it opens up the SPL config window. Here, you are able to set color-changing values based on SPL thresholds as a visual reference to noise levels. All levels exceeding these thresholds will change to its corresponding color: gray for lower values, green, yellow, and then red. A single LEQ or equivalent continuous level can be selected with an A, C, or non-frequency weighting. The time period for the equivalent level can be typed in minutes. In all versions of Smaart, calibrated sound level can be plotted on the RTA graph. To do this, navigate to the spectrum view by using the hotkey S, or going to View under the measurement engines and selecting Spectrum. Click on the settings icon at the bottom right of the RTA graph, and in the pop-up window, select the tick box Plot Calibrated Level. Now you will notice that the SPL values on the RTA graph are calibrated SPL values. For more advanced SPL measurements, Smart Suite and Smart SPL, the standalone version, are the go-to options. The standalone version SPL is included in Smart Suite. This can be accessed by selecting SPL in the top right corner above the SPL meter, or open up Smart SPL independently. If you have not calibrated any inputs, Smart will prompt you to do so in the top central window. You can also calibrate additional inputs by clicking the Calibrate button at the bottom right of the Smart window. Follow the same steps as explained before. Without doing this, you will have no available inputs for SPL measurements. Smart SPL does not consider spectral information unless instructed with custom metrics. On the left, you will find all previously logged SPL data. The top center will display all currently calibrated inputs. The center navigation window displays a single SPL metric at a time, and the bottom main graph window displays an overlay of multiple selected SPL metrics. These two graphs provide level over time data. In the control bar on the right, there are some basic action and configuration buttons. To start logging SPL over time, press the Start Logging button. This will turn red and the measurement graph will become active. You are able to add notes to the time graph by pressing either spacebar or the Add Note button. Apart from the single input at the top center, you are able to open a separate window of meters. Do this by pressing the Show Meter Grid button or pressing the hotkey E. This window can be sized larger and smaller by dragging the bottom right corner. You can also customize this window by adding more rows and columns and setting the input and meter metric for each block individually. While logging, your mouse cursor position on the measurement graph will provide you with a level, time, and date readout. To stop the logging, simply press the Stop Logging button. The trace will be stored in the data window on the left. In the navigation window, the time period can be cropped by using the left and right cursors. At the bottom of the main graph, the max, L10, L50, and L90 levels are displayed for the foreground trace. The total time range can be seen at the bottom right of the main graph area. More customized features can be found in the Log Config window. Open this window by pressing the Log Config button on the control bar. Here you will find 4 tabs. In the Logging tab, you can set the data capture interval time period in seconds. This will determine how frequent a data sample is recorded. You can also enter details specific to the project that will be presented in the exported report. In the Custom Metrics tab, you can add or remove additional metrics by pressing the plus or minus buttons at the bottom left. Here you can add specific metrics with regards to time weighting, time averaging period, frequency weighting, and spectrum band. In the Alarms tab, you can set the threshold where, if exceeded, the screen will flash for a specified time and the alarm will be recorded into the log file. In the Display tab, you can adjust the line thickness for the time-based traces. You are also able to set custom color changing features for the meters. Set a level threshold for green, yellow, or red based on your preference or application. When you have completed your SPL log, you can export the data in a PDF report. Press the Generate Report button in the control bar. This will open up the Generate Report window. Here you can add additional information regarding the project. You can then select which metrics you want to include in the report. You have tick box options to open the file location or to email the PDF report. Once all selections have been made and information completed, you can click the Create button. Rational Acoustics has created a very useful spreadsheet to provide in-depth information regarding system headroom for SPL measurements. You can find this document downloadable on their support page. If you do not have a standalone calibrator, but wish to do some SPL measurements, you can use the following formula to get an estimate of your system's calibration offset. You will need to know the sensitivity of your microphone presented in millivolts per Pascal and the input gain of your interface, given in dBu. You also need to ensure that the preamp on your interface is turned all the way down. Please note that this is not the correct method of calibrating your system, but I give you this tool so that you can start playing around with SPL measurements. To do this properly, you need a calibrator. Have fun and chat soon.